Hi there, hope you have a fantastic day. This lesson, I will go through 2024 HSC paper with you. Of course, there is a PDF file version on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First of all, we know that this series has a limiting sum. So in another word, sum of infinity is equal to a 1 minus r. And we know that a is the first term. Let me just write this down. A is x, term 1. And the common ratio r is term 2 divided by term 1. So that is x. So a is x and r is equal to x. So we just substitute that into the limiting sum. So that means I can just write s is x over 1 minus x. So there you go. The question is, by considering the graph, y is negative 1 minus 1 over x minus 1, or otherwise, find the range of possible value of s. So in another word, we just need to find the range of y. But if you think about it, okay, let me just make it into one fractions. So let me just write this down first. So if we write y is negative 1 minus 1 over x minus 1, that can be equal to negative 1 brackets x minus 1 minus 1 over x minus 1. So this is the same. And if I remove the brackets, I will get negative x plus 1 minus 1 over x minus 1. Of course, these two cancel out. This will give me equal negative x over x minus 1. Now with the denominator, if I take the negative 1 out, so that will give me equal negative x over negative. So x become negative x plus 1. So that is negative x plus 1. But negative x plus 1 is the same as 1 minus x. So let me just rewrite this for you. So become 1 minus x. And these two negative cancel out. So that is equal to x 1 minus x. So that is exactly the same as the limiting sum. So there you go. So this is also equal to s. So keep that in mind. So now we need to find the range of this. It will give us the range of the limiting sum. So to do this, so we just do a quick sketch, okay? So let me just divide this first. So now let me just quickly sketch y equal to negative 1 over x minus 1 first, okay? And what we do, we minus 1, that means we move 1 down, okay? So that is just same as this. If a minus 1, it moves the graph, move 1 down. So let me just quickly sketch this first. So we know that the x cannot be equal to 1. So 1 is here. Then we can just find the y-intercept. That means when x is 0. When x is equal to 0. So when x is equal to 0. So this means y equal negative 1, 0 minus 1. So give me 1. So there you go. So 1 is here. And when x approach to infinity, y becomes 0. So if you think about it, it is a hyperbola functions, okay, like this. So your graph should look like this. So there you go. Now it's moved down 1 unit. So if I minus 1, So the graph moved down 1 unit. The horizontal asymptote becomes -1 instead of 0. At the moment it's 0. So I just write this down here. So let me clear this first. So now move down 1 unit. So we'll be like this. So there you go. And we know that the limiting sum, that is R, must be between -1 and 1. Keep that in mind. So for limiting sum, the condition is R must be between 1 and -1. But R is X in this case. So X must be between 1 and -1. So in another word, when X is -1, so -1 here, so we have the y value here, we need to find out. So when X is equal to -1, so we can substitute either in this function here or this function here. Doesn't really matter, okay? So when X is -1, so Y is -1 over 1 minus -1. So that becomes -1/2. So this one here is -1/2. So in another word, the range for this graph is from this onward, okay, for limiting sum to be exist. So that is, the range is from -1/2 to infinity. So there you go. Question number 31. First of all, we know that the area of QRST is A. So the shaded area is A. Remember that. And we know that area of a sector is 1/2. Let me write it down here. 1/2 R square theta. So therefore, we just need to find the area of the larger sector minus the area of the smaller sector will give me A. Okay, keep that in mind. So let me just write the larger sector first. That is area of Q or R. Q or R. That will do. So it's 1/2 R square theta. But the radius is 1 plus X because we work out the larger area of the sector. So this is 1, this is X. So 1 plus X is the radius. So the 1/2 1 plus X square theta. So there you go. And the area of TOS, let me write this down. So area of TOS is 1/2 R square theta, but this one R is 1. So times 1 square times theta. So that means 1/2 times 1 times theta. So that is 1/2 theta. So if we minus from each other, the area is A. So keep that in mind. So let me just write it down here. So 1/2 1 plus X square theta, we minus 1/2 theta is A. So let me write A here. And if I times 2 on both sides, so that becomes 2A is 1 plus X square theta minus theta. And if I take the theta out, so that will give me theta 1 plus X square minus 1. So there you go. And if I expand the 1 plus X square out, so that will give me theta 1 plus 1 times X is X, with double, give me 2X. And then plus X square and minus 1. So now these two cancel out. So that will give me equal to theta X squared plus 2X. So there you go. So theta must equal to, so theta equal 2A over X squared plus 2X. So please keep that in mind for me. Now we know that perimeter of QRST is this. So we have x here and we have another x. So 2x at this arc length first. So let me just write this down. Perimeter is equal to 2x, that is 2x here, and this arc length here is L is r theta. R is 1, so equal theta. Let's make that L1, and this L2 here is r theta as well. So r is 1 plus x, and then we times theta. So now we know that the perimeter is 2x plus this and plus this. So let me just write this down. So we plus x plus 1 theta at theta. So there you go. But now we know that theta is this. So keep that in mind. So I just replace with theta. So that is 2x, we add x plus 1, and then we times theta. So theta is 2a x squared plus 2x. We add theta, so 2a over x squared plus 2x. Now I can make this as one fractions because they are the same in common denominator. So that becomes like this. 2x, we add 2a brackets x plus 1 plus 2a over x squared plus 2x. And I can take out common factor. So that will give me 2x, we add, I take the 2a out. So x plus 1, we add 1 over x squared plus 2x. So I can just simplify this further. Of course, this add together give me 2. I can take out the common factor of this by taking out the x. So I just go equal to. So P of x is equal to, so I take 2x plus 2a x plus 2 brackets, and I take the x out, so x plus 2. So that is equal to, so these two cancel out. So therefore, that will give me 2x at 2a over x. So there you go. That should be the same as above here. So there you go. So 2x plus 2a over x. So there you go. Now, part B. Show that the perimeter px is minimized. So in another word, px is minimized. So that means the second derivative must greater than 0. So somehow we need to show that is greater than 0. So let me just write the function down first. So we know that p of x is 2x at 2a over x. Let's just double check. 2x, 2a over x. That is correct. So now let me differentiate this first. So p dash x is 2 minus, so remember this is 2ax minus 1. If I bring the x up, we differentiate that. So that will give me negative 2ax minus 2. Okay, keep that in mind. So I write it down here. So there you go. And of course, I need to differentiate one more time to find the second derivative. So p double dash x, that will give me, so that becomes, differentiate 2, give me 0. So this, bring it down, become negative 2 times negative 2, give me 4a x minus 3. and I bring the x to the power of negative 3 down, become positive. So that is equal to 4a x power of 3. Okay, keep that in mind. So since a is greater than 0, x is greater than 0, so therefore p double dash x is greater than 0. Therefore, px is minimized. So there you go. Now we need to show that angle theta less than 2. So to work this out, first of all, we just find x first. That is when p dash x is equal to 0. And then once we get x, we're going to find the angle theta. Okay, we already found the angle theta is here. So we just need to find x, and we substitute the x into this equation here. So let me just find x first. So p dash x is equal to 0. So this means that this one here is equal to 0. So that means 2 minus 2a x power of negative 2 is equal to 0. But x to the power of negative 2, I bring it down first, become positive indices. Okay, keep that in mind. So that is 2 minus 2a x to minus 2 becomes x to the power of 2 here is 0. If I times x squared on both sides, so this will give me 2x squared minus 2a is 0. Then I move the 2a on this side becomes positive. So that means 2x squared is 2a. And I divide everything by 2, so that cancel out. And I square root both sides. So that means x is plus or minus square root of a. And since x is positive and a is positive, so I just ignore the negative sign. So that means x is square root of a. So now we can find the angle theta. So let me just draw this down. So angle theta is this one here. So 2a over x squared plus 2. So let me write this down. Theta is 2a x squared plus 2x. And we know that x is square root of a. So that will give me 2a over, and x is square root of a. So square root of a squared give me a. Keep that in mind. And we add 2x. X is square root of a. So there you go. But then we need to show this is less than 2. So if you think about it, okay, so if you ignore 2 root a, so that becomes 2a over a, correct? So let me just write it down here. So since 2a over a is equal to 2, but then we add 2 square root a, which is a positive number, on the denominator, so therefore the angle theta must less than 2, correct? So let me just write this down. So therefore is less than 2. So therefore angle theta is less than 2. So there you go. Thank you so much for watching. Bye.